All right, this is the last of the worksheets that you need to review for the midterm. I'd like you to collect all 5 of these worksheets into one spot so that you can turn them all in. You'll notice that in your grade book, there's 5 assignments that are called midterm review, and then there's the midterm. I want all that stuff turned in on the same day. All right, so this is the last of those assignments. It's about correlation. Correlation tells you how together a group of data are. So for example, I have some data here. In other words, I have a bunch of coordinates, and these are kind of together, and so they're kind of correlated. So correlation is a measurement of how together a group of data are. All right, so number 1, it says, plot one point on the graph and then click Show Line. Why do you think a line is not graphed? All right, and I have a little tool here that I'm able to do that. I'm going to put one point right there, and then I'm going to click Show Line, and it doesn't matter what I do, no matter how many times I click Show Line, it doesn't give me a line. So why is that? What if I put 2 points and said Show Line? Now I get a line. So why is it that 1 point doesn't give me a line? Well, you have to have 2 lines. You need 2 points to make a line. Okay, so on our graph, we need at least 2 points in order, at least 2 points to make a line. But you could also have more than 2 points. Okay, so that's what we're talking about today. What if you had more than 2 points? What kind of a line would you get? Okay, but it wants us to put 2 points on, so I'm going to put -10, -2. I'm going to try to pick whole numbers, so it's a little bit tricky. And then let's go all the way up to 0, 6. Okay, so the 2 points that I'm going to put are -10, -2, and 0, 6. All right, so I'm ready to put my 2 points here. Girls, I'm trying to make a recording. So the first point was, I've forgotten it already. The first point was -10, -2, and 0, 6. Okay, so -10, -10, -2. Okay, and then the second one is 0, 6. All right, so let's turn those into an equation. All right, so this is going to be easier to graph if we set a scale. So I need to go halfway so that I can draw a line halfway, and then halfway this way would draw like this. Actually, let me draw some real lines. So halfway is right here, about like that, and then halfway is about right there. If you would, please go ahead and label your graph with me so that you can see where everything is. Okay, and then the first point that I put was -10, -2, so that's -2, 4, 6, 8, 10. All right, so the lines here on this graph go by 2s. In other words, the interval is 2. So this is -2, -4. Okay, and the first point that I put was over here, and that was at the coordinates -10, -2, and I've also put a point at 0 here, 6, which is right about there. And then if I want to connect those with the line, it looks like this. Okay, so if you would please, would you make this graph on answer to number 1. So this assignment is all about making lines, and in particular we started, it said, with 1 point, and we found out that you can't make a line with 1 point. You need 2 points to make a line, and now we're doing 2 points, and then later on we'll do a whole bunch of different points. All right, so that's what this assignment is about. We've got 2 points here, and I need the slope and I need the intercept. So I can go ahead and just highlight what the intercept is. The y-intercept is where the line intersects the y-axis, and I gave you that point. It's right here. And that's the coordinates 0, 6. You can tell that's the intercept because the x value is 0. So this is the coordinate 0, 6. And that means that the intercept b is 6. So I'm already halfway there. In the equation mx plus b is 6. I still need to calculate the slope, and I'm going to do it with these 2 points. So please label the first coordinates x1 and y1, and then the second coordinates are x2 and y2. So we've done this a whole bunch. Now I'm going to do the slope, which is y2 minus y1. That's the rise over x2 minus x1. That's the run. And then I can put it in mx plus b form. So y2 is 6 and y1 is -2. So that's 6 minus -2. And then, so 6 here minus negative 2. And then the next one is x2 minus x1, so 0 minus negative 10. All right, so 6 minus negative 2 divided by 0 minus negative 10. So keep, change means that I change these two into positives, and keep, change means I change these into positives. So the rise is 6 plus 2 is 8, and the run is 0 plus 10 is 10. Now the slope is the rise over the run, so y2 minus y1 over x2 minus x1 is 8 divided by 10. That's the slope. Okay, so that's the slope formula. And this can be simplified because the numerator and the denominator both have a common factor of 2. So I can divide both by 2. 8 divided by 2 is 4, and 10 divided by 2 is 5. So that is the slope. And this was the intercept. And now I'm ready to put those into slope-intercept form. Alright, so it says find an equation for a line between these 2 points, and we've done all the work that we need to. We have found that the intercept was 6 because we know that the line started at 6. That's where it goes through the y-axis. And we found that the slope was 4 over 5 when we use the slope formula y2 minus y1 over x2 minus x1. And now I'm ready to put those into the equation, y equals mx plus b. So I can replace m and I can replace b. So that means that y is equal to 4/5 x plus 6. And that's the equation of this line. Now, the computer can do that for me as well. So that was kind of an elaborate, I wanted to show you all the steps that you would have to do before the computer does it for us. It says click show line and then compare the equation for the line drawn to the equation that you calculated. The computer, I think, is going to give me a decimal when I do this for 4/5 because that's a fraction. So let's see. I've still got my 2 points, the one here at negative 10 comma negative 2 and the one here at 0 comma 6. And then if I click show line, then it's going to draw that line for us automatically. And yeah, look at here, it did the equation that it gave us, y equals 0.8x plus 6. It gave us the equation that we wanted, but it gave us this decimal, 0.8. And so I need to make sure that I understand what that slope is right there. This is the slope right here, 0.8, and this is the intercept, 6. And I got that by clicking show line. Okay, so let's write down what is right there is 0.8x plus 6. So when I use the computer, it told me that the equation was 0.8x plus 6.0. And it's pretty easy to see that obviously 6.0 is the same as 6, so that's what we wanted. And it's less obvious that 0.8. Well, wait a second, isn't that different than what I calculated? Okay, so let's look at what 4/5 is. Of course, those of you who are listening are probably predicting that if I were to put 4/5 in, I would get 0.8. And of course I do. So the slope that I got, 4/5, is the same as the slope the computer gave me, 0.8. Okay? So it says compare the equation for the line drawn. So I need to write down the computer's slope was 0.8, which was a decimal. But that's the same as 4/5. So it appeared to be different, but if you knew your decimals and fractions, then you would know that 0.8 was the same. And then of course 6.0 is the same as 6. So we've got an equation here. In other words, I've just proved to you that this little calculator, when I click show line, is going to give us the equation of the line. No big deal. The next page, would you turn your page over, now that we've done 1 dot, you can't make a graph. 2 dots, you can make a graph. It's mx plus b form. What about 3 dots? It says clear the graph and plot 3 points and think about a line that fits those 3 points. So I'm going to clear, and this time I'm going to put 3 points, but they're going to be in weird spots. So these 2 would make a line, but what about this one over here? So now these 3 dots aren't all on one line. So it says, number 1, is it possible for a single straight line to go through those 3 points? And the answer is, of course, no. No, you'd have to make a crooked line by connecting dots. Go ahead. All right, so it's asking about this graph here. These three plots, is it possible to make a line that goes through those? No, it's not. And then let's duplicate the graph down here on a piece of paper, plot these 3 points, and sketch a line that goes through. So let's make a real graph here. So let's see, again, I need to put the y-axis because it's hard to see otherwise. And I need to put the x-axis. And then let's pick some real points so that we know exactly where they are. So like our points could be, let's do -6, +2. So -6, +2, let's try that. And then 0, 0 is always good. That one's easy to plot. And maybe one way up here. So how about 2, 4, 6, 8, 8, 8. All right, so what if we plotted those 3 points? Now, obviously, you can't get through all those 3 points, so let's sketch a line, a single line that goes as close to those 3 points as we can. So it may be like this. So I'm not going to be able to connect the dots, but I can get, like there's one above, one below, and then one right on top. So that's as close as I'm going to be able to get to. So what you do is you put your ruler down once, and then you draw the line that gets as close to the dots as you can. All right, and the name for that thing, the thing that I just drew, is the line of best fit. It's not the line of perfect fit, it's the line of best fit. So this dotted line here gets as close to the dots as I can. So now I've put this into the little calculator tool. I've got my 3 points that I said that I was going to try to connect, and then I'm going to click Show Line to get as close as I can. So I'm about to draw the line of best fit, and there it is. So the actual line of best fit, I picked one that went exactly through this point, and the real one, it didn't actually touch any of these dots. Okay, the line of best fit does not actually touch any of these dots. Okay, so let's answer this question down here. I'll get to you in just a second, Nadia. It says, click Show Line. Do you think that the line graphed fits the points well? Yes, it fits the points, even though it does not touch any of them. And then how does it compare to the line that we drew? Ours, so this is ours. This was above, this was below, and it was pretty much on top. And the correct one was above, below, and then it should have been a little bit lower. So my graph was steeper. My line of best fit was too steep, maybe. Or something like that.